Hello, everybody. My name is Noah McGregor, and I'm presenting my research project on PFAS and how cities are tackling emerging contaminants in drinking water. So, a little background on PFAS. They're also known as forever chemicals. This is because they have long chains of carbon-fluorine bonds, which is one of the strongest bonds in chemistry. And these bonds make them incredibly resistant to natural breakdown, meaning they can last in ecosystems for hundreds of years. They've been linked to things such as cancer, immune system suppression, thyroid disruption. Um, and one of the main reasons there's such a big issue now is because over 176 million Americans are estimated to have PFAS in their drinking water, and traditional water treatment techniques such as chlorination and filtration cannot remove PFAS. They require highly advanced and very expensive methods to remove them from water. And there are over 12,000 classes of PFAS, and depending on which one, whether it's a short chain or a long chain, the treatment method varies. So it's a very complex issue to treat. So the main research question we're focusing on is how are cities addressing emerging contaminants such as PFAS in their drinking water and wastewater systems? So the two cases we selected are Wilmington, North Carolina, and the state of Michigan. These were selected because they're both very different cases, but they both provide excellent sources of data and analysis. The four source types we're looking at are peer-reviewed literature, government reports, legal documents, and biomonitoring data, as this gives us multiple perspectives on this issue and plenty of valuable data. And to analyze these cases, the things we're going to be looking at are the source of contamination, the health consequences, the treatment, and how the government responded to the PFAS outbreak. So the first case study we're going to be looking at is Wilmington, North Carolina. This all began in 1980 when the DuPont company was discharging Gen X, a PFAS chemical, into the Cape Fear River from one of their factories. It wasn't until 2017 when Star News investigators exposed the contamination to the public. In 2019, DuPont was required to take responsibility for the contamination and install a barrier wall and treatment. And not until 2022 was $44 million invested to install granulated activated carbon filters at the local water treatment plant to prevent the public from consuming PFAS in the drinking water. However, by then, countless Wilmington residents already had PFAS in their blood, and this is likely why they were way higher than average rates of thyroid cancer in the Wilmington area. So to treat this, it cost over $44 million for proper treatment methods to be installed, and most of this was paid for by taxpayers, not by the company themselves. Next case study we're going to look at is the state of Michigan, who had a far more proactive response to the PFAS issue. So in 2017, multiple PFAS sites of contamination were identified, and the state formed MPART, which is a multi-agency team designed specifically to tackle PFAS. In 2019, they tested all 1,500 of their public water systems to get accurate readings of the PFAS levels. And in 2020, they set maximum contaminant limits for 7 PFAS specific compounds, which were far stricter than the federal limits. So the specifics of MPART, 7 state agencies were unified to work together to prevent PFAS contamination, including environmental groups, health groups, agriculture and natural resources groups. However, despite this proactive response, contamination still continues at military bases due to the use of aqueous film-forming foams, which are used to fight fires. Now we're going to look at a little comparative analysis, and the key things to focus on here are, number one, the contamination type. So in Wilmington, it was a single point source, just one release point from a company that was negligent. Meanwhile, in Michigan, the PFAS sources are very diffuse, came from a variety of different places. The discovery in Wilmington was actually from investigative journalists that made the story public. Meanwhile, the PFAS levels found in Michigan drinking water was actually from the state monitoring program. the government response in Wilmington was very reactive, very delayed, and driven by litigation. Meanwhile, the Michigan response was proactive and had a established agency just for PFAS, so that was far more effective. So some recommendations for cities in the future looking to tackle PFAS in the drinking water, based on these two case studies. Investing in early monitoring is absolutely crucial. We need to identify these risks before a crisis strikes, like it did in Wilmington. We need to establish maximum contaminant levels. This basically writes into law that PFAS needs to be at this level or lower, or there will be legal repercussions. And this really forces treatment plants and the government to up their game and provide the public with clean and safe water. We need to strengthen polluter accountability. The DuPont company didn't face any repercussions until decades after, which allowed them to dump more and more PFAS over the years into the water, potentially harming thousands and thousands of more people that could have been protected. We also need to pair treatment with equity. As I said previously, treating PFAS requires advanced methods and it's very expensive, and not every place can afford that. And these places weren't the ones that polluted their waters with PFAS. Oftentimes it comes from major corporations, so the government needs to step in and assist some low income areas with funding to help treat PFAS in their water. And thank you everyone for listening to my project.